today. If
you're like halfway done with dinner,
then I'd probably just stand here and hang out. Because we're going to go kind of quick. So, if we think back to the days of Pythagoras and Euclid and Socrates and all these famous mathematicians or, these guys have lots of different titles. But if we think back to these days, they did not have fancy schmancy mathematical modeling tools. They maybe had something that was straight, that they would call a straight edge. And they probably have a compass, because that was a fairly early invention. And they might have a protractor. But let's say we want to draw a rectangle freehand. So what qualifications does a rectangle need? What does it have to have true to be a rectangle?
all right angles.
All right angles, so I'll need to notate the size of the angles. Andrew?
4 sides.
4 sides, so it's got to be a quadrilateral. Not like that's it? Nobody else other than Abby and Andrew?
I got it.
Abby?
Isn't it also two sides need to be like the same, like, so there's two, so pretty much you have two parallel lines, but they have to be the same measurement. Like,
So they have to be
this has
congruent.
the same, yeah.
Yeah, so we have 2 pairs of congruent opposite
That's what I'm
sides,
trying
I think
to
is what you're
find
trying to say.
out.
A lot of people, draw a rectangle up here. Do it the best that you can. But a lot of people, when they're asked to draw a rectangle, draw something like this. Now, mine's not perfect. I'm going to try to make it a little bit better. But it doesn't have to be perfect. Because we're going to label the things to make it true. How do we show right angles? Draw the box. So in each corner, draw the little box. How do we show that lines have the same lengths as each other? How do we show congruence?
What?
Yeah, but what if we can't measure? Like, what if I don't have a ruler? Reagan?
So you put like those 2 little lines and like both.
However many lines you choose.
Yeah.
So yeah, Reagan just said we can show those 2 little lines that say, hey, that's the same length as that. But actually, it's just however many lines you have, or really whatever symbol you have. So I could put a single line on these sides to show that those are also congruent. Now, there's something else that I think we've assumed, but we haven't yet stated. If I continued these lines out, would they ever touch? What does that mean that they are? Parallel. Does anyone know how to show parallel?
There's some note there for you, but you draw like a little line, like a little arrow.
You draw a little arrow that says both of those keep going to the right forever and don't touch. And then use a different amount of arrows. 2 arrows will say that these are going to continue forever and would never touch. This is now technically a rectangle.
Yay.
Up until that point, we didn't have all the information to show that it is exactly a rectangle. Now, if these are all right angles, the parallel has to happen. So we've kind of been a little bit redundant here, but that's okay because we want to be as specific as possible. So I want you guys to try to do challenge A and B. What about a quadrilateral with only 1 pair of perpendicular sides? Ooh, perpendicular. What does perpendicular mean versus parallel? Anyone know what perpendicular means? So off to the side here. The symbol for perpendicular is this. It's an upside down T. Abby, what's it actually mean to be perpendicular?
Doesn't it mean that they're parallel, not parallel, but they form a triangle, but they can intersect?
Not quite.
A right angle.
They form a right angle. So to be perpendicular means that they form a right angle. So try challenge 1 and challenge 2. We want exactly one pair perpendicular or two pairs parallel and no right angles. So these are two different challenges. Now, does this tell me anything about side length? Anywhere does it give me inches or centimeters or millimeters or anything? Nope. Does it tell me anything about angle size? Kind of, right? Because if one pair's got to be perpendicular, that means I've got one angle that'll measure 90 degrees. Either use your protractor, or if you're good at drawing freehand, you should have a 90-degree angle. The other two sides don't matter, as long as you don't make them perpendicular. So you cannot do this. That would not work because this is perpendicular. Like, that makes a right angle. But I could make this work if I do that. Or, I'm just going to draw a bunch of options. I could do that. That's still a quadrilateral with one right angle. I could do this. Still a quadrilateral, still one right angle. I've got tons of options here. All that mattered was that I had one right angle. So there's really not very many wrong answers there. Two pairs of parallel sides and no right angles, well, crap. If it just wanted two pairs of parallels, I could use my rectangle. But it doesn't want any right angles. What's it called when I have two pairs of parallel sides? It's a quadrilateral, but none of my angles are right angles. We default, instead of a rectangle, because a rectangle is this type of shape, but without the right angles, it changes names. Julia? That's exactly what it is. So we need to draw a parallelogram. So whatever you start your bottom side, your top side has to be parallel with it. Whatever your left side is, your right side has to be parallel with it. And actually, in a parallelogram, also what's going to happen, my top and bottom will be congruent with each other. My left and right will be congruent with each other. Any questions about how we got our parallelogram? Any questions about the shape details here? What we can or cannot do? There's a lot of possible parallelograms. There's a lot of different ways to draw a parallelogram. But now we want only one pair of parallel sides. You may want to notate, by the way, up here that this was a parallelogram. So if you did not think about that, please go ahead and label that that was a parallelogram. Because we're going to name this shape then. If it's got one pair of parallel sides, well, my left and my right can't be parallel. Well, okay, I could make like a long base and a smaller top and say, okay, these are parallel with each other. They're not the same length, but they're parallel. Andrew, what kind of shape is this? Trapezoid? It is a trapezoid. So we've now talked about rectangles, parallelograms, trapezoids, and just general quadrilaterals that might have some kind of specific detail at once. Any questions so far? Abby?
By the way, I'm just going to ask this. trapezoids aren't parallelograms, right?
Correct,
Because
because
this part can they're gonna intersect with each other.
Yeah.
At some point.
these lines, if I continue them, would intersect. And that's what makes it not a parallelogram, is that these two sides are not parallel. So as soon as a trapezoid would become a parallelogram, we would not call it a trapezoid anymore, because it wouldn't be. It would then be a parallelogram. But that's why this is trapezoid, not parallelogram. So now we got a lot of details. Do you have a ruler and a protractor? If not, grab both, please. So this is a math count shirt because I had Great Lakes under my armpits this morning. I was pit sweating. Between the school climate and just stress of life going on. But so this over here is the function for finding the average. So 1 divided by n, how many numbers you have, the sum of all of your numbers. So my first value up to my top value. Then, you don't really have to worry about that, but that just means like we're going to put them all together. And then this will divide by how many you have. Put them all together, divide by how many you have. That's how you get the average. B greater than the average. So that was the math count shirt. This year's B greater than average. When you're given details about a shape, do you think it would be easiest to start by trying to draw an angle or start by trying to draw a side? Yeah, why wouldn't I start by drawing an angle?
Because you don't have anything to base off.
Yeah, what the crap can I put the angle on if I don't have any sides yet? So I see people often, they have nothing drawn and they're using their protractor. I'm like, excuse me, what are you doing? They're like, oh, it told me a 60-degree angle. Okay, but if you don't have any lines yet, you can't make any angles. So choose a length. Let's choose the 4-inch side just because it's longer, it's easier. So, you can change units if you want. If you want your shape to be smaller, change that to centimeters, or change your inches to 2 and 3, or whatever you want to do. We're just going to have to label everything. Once I draw one side, I then want to go do an angle. So, I've got my 4-inch side. I now need 2 60-degree angles, 2 120-degree angles, and I still need to pick up 2 3-inch sides, and I know it's a parallelogram. Well, the side connected to my 4-inch, will that be a 3-inch or a 4-inch side? If it's a parallelogram. It's going to be a 3-inch because my congruent sides have to be opposite of each other. So, I want to start, I can do either of these, but I think the 60-degree is easier. So, set your protractor over on your left vertex. Set the T of the protractor right on that. You'll notice that your 0 goes through out here now. So measure up your protractor until you get to 60 degrees, which would probably be, that would be like 45, so 60 would probably be about here.
Oh, that's
And you can draw it longer than you need, and then go back and erase what you don't need. So if you draw it extra long, and then you come back and erase it to be 3 inches, then we're good.
wait.
And you need to label that we made this 60 degrees. Now I know this is a parallelogram, so attached to this side on top needs to be a side that is parallel to the bottom. What else do I know about that side? It's not only going to be parallel to the bottom, it's got to also be, what's that C word that means same size? Congruent. So if that was 4 inches, this must be 4 inches. So I probably have to extend it a little bit longer. I can label that 4 inches. If you measure this angle, or if you set it up using the protractor, this is going to be 120. Now here's the other thing that you're able to do. Give me your eyes for a second. If you had just made your 60-degree angle, you know that when you come over here, if I made another 60-degree angle, it'd be coming inward like this. And we know that that is not going to make a parallelogram. So what we can see is my 60-degree angle. That was bad. If I have 60 on one side, my other side has to open 120. And if I made that 120 and extended it, it's 3 inches. Then when this 4-inch side comes over, they should meet right here and be that fourth 60-degree angle. I would also want to notate this side is parallel with that side. They are the same length. And now we have everything labeled. Any questions?
This is getting hot.
You will not be asked to do tons of this. You just have to understand how to work with a protractor, how to work with a ruler. On the state tests, they actually have digital rulers and protractors that you can use, which a lot of people sometimes like the digital protractor better because it's easier to kind of click where you want it to be and it doesn't move on its own. We will practice with those, so don't worry. We'll do some practice with the tech. So try to sketch this figure. A rectangle with 2 4-inch sides, 2 2-inch sides. So first think to yourself, is it possible so when I think about what makes a rectangle, Michaela, can I make a rectangle that has 2 sides of 4 inches and 2 sides of 2 inches? Yeah, because it doesn't tell me anything about the angles. And I know in rectangles, I have to have opposite sides that are the same. So just like what we drew up there for a rectangle, I could draw a 2-inch side, and then a 4-inch, a 4-inch, and a 2-inch. What else would I need to label to show that this is a rectangle? Well, so I've labeled these, so it actually tells me that they're congruent. So I don't need the congruent line since I know what length they are. I could do the arrows, but I actually don't need those either if I show one other thing. If I show this, if we show that box, and I know my top and bottom are both congruent, and my left and right are both congruent, then we, as intelligent mathematical people, know that this will have to be a right angle. I don't have to show it. It has to be that way. This has to be a right angle, and this has to be a right angle. You don't have to show all of those as long as you show one of them, and the side lengths. If you didn't show the side lengths, you'd probably want to show all the right angles, and vice versa. Any questions? Try that triangle. Now again, it doesn't tell you a side length, but I would do a side first. You can't make an angle without a side. Jack, what are you thinking? You gonna get a triangle here?
Yeah.
Okay. So I come over here and I line up my T on my protractor. Then I realize my 0 comes over to the right side. So I would use that set of numbers up to 100. If I go all the way to 100, it's gonna be like out here. So there's my 100-degree angle. I flip to the other end and I line up my T on my protractor, now my 0 would be over here. So I use the other set of numbers and come up to 100. And if I did this right, I should end up with this. Now, Jack, is that a triangle? Why not? It doesn't close. This is not even a polygon. Because to be a polygon, it's got to close. So this can't be made. And it's really dumb. Well, corny. But right here. If you forget your rule, it's on that poster. No matter how hot or cold it is outside, on the inside of a triangle, the interior triangle angles. So, interior angles of a triangle. I'm trying to do shorthand for you. Interior angles of a triangle must sum to 180 degrees. What do 100 and 100 sum to? 200. We've already got too much. Our angles are way too big. What are two angles on the bottom of the same size that could work? Andrew?
80.
Yeah. If I did like 80 and 80, what's 80 plus 80?
That's
160, and I still have 20 degrees left over for that top angle. But this one can't be made because the interior angles of a triangle must sum to 180. Any questions on that? Preguntas?
Oh my god.
It's more of a, it's more fun to say. Two sides of 1 inch, two sides of 3 inch, and at least, you're given an angle, and you're given 4 sides. Hayden, how should I start this? How are you going to draw a right angle if you don't have any sides? Do I know how to draw those yet? Like where to draw them? Whenever I start drawing a shape, I want to start by drawing what first? Start with an edge. Start with a side. So when you said make a right angle, I really have to draw a side before I can make the right angle. So, my advice, do the bigger side you've been given. It's just easier to start with the bigger. So do your 3 inch side. Then we can do an angle. So, do you want to go left side or right? Like left point or right point? Left? Sure. Now, how long is that side going to be? Sure, we can make it 1 inch. Now here's the fun part. What's my next side that I draw? Sure. But what if, on the right, I get crazy? I make that my 3 inch. Could that be allowed? Did I make my right angle? I'm trying to check boxes here. Did I make my right angle? Yes. Do I have two 3 inch sides? Yes. If I can connect this with a 1 inch side, that would be a fine shape. And actually, if I want to draw it and make it look a little nicer, A little bit long there.
It's not
This is not to scale. It's not drawn the right size. We can make what's called a kite. Now, we could have what your brain probably thought of here. Three, 3, 1, 1, and a right angle. That would be fine. We could make a rectangle. But based on what they told us, we don't know that it's a rectangle. These could be right as well. Abby?
But so I did the ruler thing, but the red line isn't exactly it.
So, if you want to see how we could make this happen, and we've got enough time, grab a compass off the bottom shelf there. And I show this in the video too, so your classmates already know about this hopefully.
Sailed the ocean blue with just a compass.
Yeah, this is what I had when you did.
So make your two 1-inch sides neighbor the right angle. So, if this loads. So I've got my 1-inch and my 1-inch. I made a right angle. We now want to make my other sides 3 inches, but I don't know exactly where they're going to be. So this is when working with a pencil is really important. I know there's some point 3 inches off of here. And some point 3 inches off of here. Where at some time they're actually going to line up. I can preserve length. So with my compass, expand your compass to be 3 inches. So I made that little mark so I know where 3 inches is, but put your metal point on the end point of your 1 inch and the pencil point on the end point of your 3 inches. So the gap between here is now 3 inches. I am going to, while holding my point and preserving that length, make a little arc. It's really hard to preserve this length accurately. So that's 3 inches from that end point. I'm also going to 3 inch from the other end point. It's got to be close. Where those two arcs intersect. Sorry, it's kind of hard to see because my protractor was really loose. This, when I measure it, should be very close to 3 inches off that end point. And this, when I measure it, should be very close to 3 inches off that end point. So when I connect these, that's 3 inches. and that's 3 inches. And we have now made a kite. Now it's kind of difficult to make, but we are going to start working in GeoGebra, which is a 3D modeling tool, or 2D or 3D, and it does the compass work for you. Like, you don't have to hold the compass, it keeps its size and you just spin it in the program. So, very easy. Huh?
Is that the new thing, that thing?
What?
The little bluish gray thing that you just.
No, that's different.
Doesn't that make sense?
That can as well. So I'll show you how that guy works.
Those things are way easier than these.
So this would work, and you need like almost 2 pencils or something like that. If I had my 3-inch length, and I put the center of this circle on the end point of my 1 inch. So center right on. And I can hold that. Then I can find, see how this point had my 3-inch marking? You may not be able to see because the focus is slightly off. But if I use this, I can arc out the 3-inch arc. Then I can do the same thing over here. Find that little marking that I had. It was actually right here. So you have to pick the right hole. Each of these holes will be a little bit further out. So this hole actually lines up. So actually the point where my shape should have crossed, this should have been the end point. I was slightly off. But yeah, these, we may just start using these instead of a compass, but the problem is, in the tools online, they're probably going to give you a compass. Because working with a compass is part of our skill set, like our standards. So a square with side lengths of 10 units. Well, square tells me we need, what about angles? Right angles, all the lengths have to be 10. So choose your units. So whatever you want to choose, let's say centimeters. Actually, I'm going to do millimeters. So there's 10 millimeters. I can use my compass if I want to. Or sorry, I can use my protractor to set up a 90-degree angle. So off the end point, I could line up my T and mark where the 90 is. And now I'm lined up to make my line, even though it won't go that far. Then depending on how good I am at drawing parallel lines, I can either line up another 90 degree or I can freehand it. And this should all line up. And there we go. Sorry, I thought I was kind of drawing off the page. And you would want to label that that's 10 and that's 10. If you want to label excessively, those are all the same length. That's parallel with that. That's parallel with that. That's like all the labeling that we could have there. That is excessively labeled. Any questions? What about a quadrilateral with one angle measurement of 50 degrees and one side of 4 units? What should we draw first here? Flynn, what do you think? Do we draw our angle first or our side first? Yeah, so choose your units. I don't care what units you use. I would probably advise against inches. So I'm going to do centimeters. I'm going to set up my 4 centimeter line right here. Now your 50 degrees, I don't care what endpoint you use, but I like the left endpoint. It seems easier. line this up and look for your 0. So I got to line this perfectly up. My T is right on that endpoint. My 0 lines up right on that line, so make it all perfect. Go up until you find your 50 and mark it. Right, it was 50, yeah. Yep. Then I got to connect those endpoints. I don't care how long it is, so I can use my protractor as a straight edge. So line that up. Now, do I know anything else? Well, quadrilateral, one angle, one side. So guys, the other parts of your quadrilateral don't matter because it didn't tell me anything. So you could honestly finish your quadrilateral like that. You could finish your quadrilateral like this. You could finish your quadrilateral like that. You could go way over here and then back down there. You've got tons of options. All that you care is that this is 50 and we need to label that as such. So we got to label that's 50, that's 4 centimeters. Aside from that, we don't care. So you've got lots of ways. Now we could make this a parallelogram. And I could make my third side another 4 centimeters. So if I do that and I made it 4 centimeters, then this line would be parallel to this line over here, and this would open up at the supplement or at 130 degrees. But yeah, you've got tons of options. A rhombus. Now, what's special about a rhombus? We're just reviewing a lot of our two-dimensional shape types. Somebody not Abby. What's a rhombus similar to, or what other shape is a rhombus? Yeah.
It's like
Kind of. Kind of. It's got a certain similarity that we want to make sure we point out. Anthony? Yeah, so it is a parallelogram, and you can tell that by these angles being the same here. So a rhombus, you might as well write on your notes. I forgot I don't have your notes page right here. So it's a parallelogram, so go ahead and write that down. With congruent sides. Or congruent edges. We can start to use edges because that's a better word. So a square is a rhombus. A rhombus is not necessarily a square. So let's try to draw this. Start with an edge. How long's our edge? 4 units. I advise using centimeters. So start with 4 units. Once you choose your units, I would label it. We've got angles of 40 and 140. So I like to do my acute first. It just seems easier. Line it up. Make sure that you are correctly on your end point, using the right 0, and then mark your 40. Here's where this gets slightly difficult. Give me your eyes for a second.
Yeah.
I know that I'm coming off this end point to this point, but I only want to go 4 units. So when I line this up, I'm going to turn my page a little bit here. Line up to your point, but make sure that you only go to the 4, or you're going to have extra to erase. So I stop at my 4. Label that angle immediately that you made that 40 degrees. The angle on the far end, or the right end here, will now need to measure 140. So again, line it all up. Then I got to use my outer set of numbers now. So go all the way to your 140 is way over here. Again, that needs to only be 4 centimeters long. So stop at your 4. Then I should be able to connect these endpoints and make a line that's parallel to the base. This will be 140. This will be 140. And this will be 40. All of these are 4 centimeters. It is time to go. So, you do not need to submit your homework. We will do 12-2 on Monday. Your homework is due Tuesday at midnight. Yeah, there's some of it you don't know about the triangle inequality theorem that you might have known from 6th grade, but you might not. Thank you guys. Have a wonderful day.